Hi guys, let us see if I can solve another problem today before starting to make my dinner. We have to show this, and I'm sure one of the formulas, I haven't book by me. One of the formulas of problem 1 will help us. So the last one, there we have to, we can't use that on chi2 and chi2. Then we have formula 2. Really? Oh, that's of chi2. Then squared equals chi2 of minus 1 times q. And this is known to be minus 1 to q times q minus 1/2. I think is the formula. That's what it, no, just q minus 1/2. Well, that makes sense, by the way. Or does it? Well, let's believe that. If q is equal to 1 modulo 4, then it becomes 4 and it becomes even. And if it's 4, 1 minus 1, then it becomes odd. Right. So that's correct. And that was what we should show. And then we shall compute this explicitly, I believe. The first two I can do by hand. I don't know about the rest. So we just have two elements. And chi2 is the identity. And psi, the additive guy, now how's that? Let us see. So this one goes to 1, and this one goes to, say, omega. Oh yeah, that was the definition. So one goes to omega, and the other one to omega bar. So d of chi2 equals omega minus omega bar. So that's square root 3 I halves Now that's strange. Oh yeah, that's true. So the square gives minus 3 as it should. All right, q equals 5. Here it begins to be difficult to compute. Well, let's try to do it by hand. etc. And chi2, then we need a generator of order 4. Now, this is not right. Oh yes. So 2 squared gives 4. 4 squared gives, of course, unity. 2 times 4 gives 3, so we can set this to -1. Then this becomes 1, this becomes -1, this becomes 1. And that's, of course, 2 is a square, so it must be 1, and the other one's -1. All right. So d of chi2 equals, and we'll just suppress 2pi fifth. These guys are conjugate, and these are conjugate. So these two give 2 cosine 72 degrees, and these give 2 cosine of 145 degrees. I actually have the values of these guys somewhere. Mabel could do it probably. Then I don't have to do it, so let's do that. Cosine 2 times pi divided by 5, and then we need to simplify constant. No. Then what can we do? Evaluate? No. It's square root 5, so I could find it by the simplify constant. No, maybe I didn't do it correctly. This is annoying. Let's do it numeric. 2 cosine minus 4 cosine 4 pi divided by 5. It should be 2 Let's see if it can simplify that. It could. And this was, oh, I forgot 2. Square root 5. Lovely. And next 7. It becomes increasingly annoying. I'd rather do, what I'm thinking about is to make a program to make Maple do it. I think I'd rather do that. So we have to have a table of chi first, and then of chi 2, and then I'll just program it in Maple. So chi 2, 6. So 2 squared gives 4. 4 squared gives 16. Modular 12, that's 4. Can't be. This is really weird. Well, anyway, 1 is a square and 4 is a squared. 3 squared gives 9, which is equivalent to... we must go modulo 7 here. 4 squared gives 2. That... Confused. This is the guy I worked on in one of the last videos, in problem 2, and then I don't even know which squares we have. Three squared gives 2. I'm really surprised here. 5 squared gives 25, that's 4. All right. 4 squared gives 16, that's 2. And 2 times 4, that gives unity. All right. So that was chi 2. And then we have we'll just make a table of it. 1.1 point minus 1 point minus 1. Oops. Minus 1, 1, minus 1, minus 1. we go. And then add. Maybe I can just write pi. Doesn't seem as if. Oh, it did. 2 pi I divided by 7 times j. This is the wrong square root minus 1. Yeah, we've got it. J times chi of j for j equals 1 to 6. Right. And then simplify, is that possible? It would be interesting to see if it was able to. What is it called? Trig, I think. That's not using tricks, that's using the trigonometric formulas. No, it can't do it. So we'll just get a numeric value. Call it x. Oh, Emma still needs the parenthesis. There we go. And then square root 7. Just to make sure. This is of course plus square root 7. It's just to make sure that I have done it correctly. There we go. So it's square root 7 times the imaginary unit. Yes. So it seems that we get square roots times the imaginary unit, and without here. So q equals 9. That was the one I thought would be more easy. That's 3 squared. Actually, I need a lot of computation to do that. No, not particularly much. I think we have done this before, but I don't have it available. In F3, we have Norton plus minus 1, and then we extend it with some polynomial. Oh, that doesn't work. Wasn't it 2x plus 1 and 2x plus 2? Let's just say x squared minus x plus unity. That should give a generator. We should have 4 generators, I think. So this is one of them. So this solution we call capital T. And then we have 9 elements. So that's our x values. Then we have the traces. And the trace of t is 2, that's -1. And the trace of minus t, it's also -1. Oh no, that's another one. I'll just have to check that in a minute. The trace is additive, so it's +1, and no, it's not. It's -2, it's +1, and t -1, it's naught. It's the one that has x squared +1. Now, -t and +2t, that vanishes, so the traces should be opposite. Oh, damn it. So it's actually +1, and this is the opposite of t -1, so that's naught. So psi is unity. And since we only have 3 values, this is omega bar, omega, omega bar, omega, unity, omega, unity. 1, 2, 1, 2, 3, 1, 2, 3. We have 9 elements, so we should have 3 of each. 1, 1, 1, omega, 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 omega bar, omega bar. Oh, I missed this guy. It should give -1, of course, but let's just check that it does. We have -t, give +1, and -1 gives 1, that's 2, that's -1, so it's omega bar. And then we have the character of order 2. So we need to see which squares we have. Those that have trace naught are of course square roots of something. So they must be that's the opposite thinking. Actually, this guy squared gives, I don't know what it gives really, we have to compute it. Squaring this gives t squared. Isn't there an easier way? I'd like to find a generator for this multiplicative group of order 8. I need that. And I think T is a generator. So let's T squared gives T minus 1. T minus 1 times T squared minus T gives unity. Ah, that wasn't good. I actually thought this was a generator. We try once again. T minus 1 and T times T minus 1 that gives minus 1. T to the 4th is minus T. That's good. T to the 5th is, that's minus the T third. And T to the 6th is minus T. T to the 7th is minus T times T minus 1, which are we missing? T plus 1. Oops, this is silly. T to the 5th is it's minus T to the 3rd, yeah. And minus T, or this can't be correct. We'll just try again. T squared minus T squared plus T, that's 2T minus 1. Yeah, we'll just go back, do it. So, minus T squared, that's minus T plus 1. It gives unity. Oops, that shouldn't be possible. So, I'll just finish it off, not recording, because finding this error is really annoying. So, and I'm having problem doing this while recording. So I'll just take a break and record them and then show you the result. All right. The polynomial I chose wasn't irreducible. It had a root, so I found a new one which has no root in F3. And there we have T in itself as a generator. On the other hand, psi is T has trace minus 1, so T plus 1 has trace minus 2, t minus 1 vanishes. Oh yeah, and now I have to think. T plus 1, yeah. T minus 1, that's naught, minus t plus 1, minus t minus 1. There we go. And now chi. So t is a unit, and minus t, now what's that? T is a generator, so it goes to minus 1, minus t plus 1, minus t to minus 1, minus 1 to minus 1. Now that's a square, isn't it? Minus 1, 1, minus 1, 1. Yes. Minus t minus 1, t minus 1, plus 1, t plus 1, minus 1. All rightio. And then the product. My God. One, two, three, 1, 2, 3. I get a sum of naught. That was not what I expected. So something's gone wrong. Chi2 can't give naught. Here it doesn't, it gives 1. So t squared equals minus t plus 1 and t minus 1, yes. And then this 2. Well, I have no idea what went wrong, so I'll stop now. It's time for preparing my lunch. It takes half an hour, and then I'll save this and check it maybe later, maybe tomorrow. As soon as I turned off the camera, I could see where the mistake was. I hope you've been laughing the whole way. Maybe we should do the trace first. I need to check the product as well. Yeah. So we take the trace first. Naught, minus 1, 1. T, that's minus 1. t plus 1 is 1, t minus 1, naught. Minus t is unity, minus t plus 1 is naught again, just check, minus t and plus 1, yep, and minus t minus 1, that's the opposite of this guy. 3 of each, good. So now we can compute psi. There we go, and the product so the sum, oh yeah, it's chi2 I have here. I did do something right. 2 and omega minus omega minus omega, and omega bar minus omega bar minus omega bar. So they must be added. So it's 2 plus 1, it equals 3. All right. That was, I expected plus minus 3, and it actually became, yes, it actually became square root 9 as it is. All right, that's it.